This is our first example on polynomial inequalities, and in this video we'll solve the inequality of x squared minus 3x minus 18 smaller or equal to 0. Now you would notice that this is a trinomial and that we can factorize this trinomial. So we have x plus 3 in one bracket and x minus 6 in another bracket. And the reason why we want to factorize this trinomial is to find values of x that will satisfy the equation of x squared minus 3x minus 18 equal to 0. So if I take each of these brackets and I set them equal to 0, I have x equal to negative 3 and x equal to positive 6. So hopefully by now you have learned about a parabola. And if I draw a rough sketch of a parabola, the values where the equation is equal to 0 are called the roots of the equation or the x-intercepts. That is the values where the graph cuts through the x-axis. Now in terms of inequalities, these are called critical values. And what we want to discuss is where this expression or this equation is smaller or equal to 0. Now looking at our rough diagram of the parabola, we can see that between negative 3 and positive 6, the parabola is smaller than 0 or below the x-axis. Therefore, x between positive 6 and negative 3 would produce values that are negative or smaller or equal to 0. That means that the other values to the left of negative 3 and to the right of positive 6 would produce values that are bigger or equal to 0. So when we interpret quadratic inequalities, we always work from the position of the x-axis. So when the values are on the x-axis, we say that they are equal to 0. So those are the roots of the equation. When the inequality is smaller than 0, then the part of the graph that we consider would be below the x-axis, or it will produce negative values. And when the inequality is bigger than 0, then we consider values above the x-axis. But you do not need to know anything about the parabola in order to solve this inequality. What we also can do is solve the inequality on a number line. So we inspect our inequality. From there, we factorize it. We use the brackets of our factorization to find critical values. And then we need to determine where on the number line would the values be positive and negative. And how we do that is I would substitute a hypothetical value of 7 in the place of x, meaning a number after 6. So if I substitute x with 7, I have 7 squared minus 3 times 7 minus 18. And that produces a value of positive 10. So we know that when x is equal to 7, that it will produce a positive value. So after 6, the inequality would be positive or above the x-axis. And now we follow a pattern of positive, negative, and then positive again. So in order to solve our inequality for where is x smaller or equal to 0, we look at the space where the equation is negative. So where it's negative, it will be smaller than 0. So x must be smaller or equal to 6 and bigger or equal to negative 3 in order to find values that will satisfy this inequality.